Hi and welcome to this on-maths prediction for the Edexcel Paper 3 Higher Tier Maths GCSE for November 2020. Enjoy! Hi and welcome to this on-maths prediction for the last paper. So, been a very long journey so far, going through the first two papers, and this is the final one. So you know the drill by now. You can click this link here and it will take you straight through to onmaths.com where you can try this paper online for free. As you know, every time you do it, it gives you a brand new paper with brand new numbers. So you're not just learning answers. In fact, there's some questions that are almost new questions each time. So it's really good for making sure that you get a grade at the start of really hard work, do your really hard work, do all your revision, and then you can do basically the same paper at the end to see how much you've improved. So it's a really useful tool. And as I say with all our predictions, make sure you do the work. Yes, these are based on historical data from this exam board. Yes, these are pretty accurate, but they're not going to be 100% accurate. So make sure you do the work, whether you go to onmaths.com to revise or mathseffect.co.uk to revise. Wherever you go, make sure you do the work first. Otherwise, I hope you enjoy it and thank you very much. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6, and then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, put a little time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. 2 minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2, it's 6. If we take away 10, it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. When numbers are quite small, it's quite easy just to do trial and error to find the highest common factor and the lowest common multiple. But when the numbers are larger, then the way we do it is with product of prime factors. Now this could come up on a paper which has previously had product of prime factors, and this is distinct enough maybe to come up in its own right. So just because product of prime factors have already appeared, this question has already done that bit for you. So how are we going to do it with these large numbers? And 3,675 and 84 are pretty large numbers. Well, the way we do this is with a Venn diagram. Now I'm going to use the space down here to do this, and what I'm going to do is, because I find it easier, I'm just going to write it not in index form. And then when I do my Venn diagram, I can just cross them out when I've done them. So 2 times 2 times 3 times 7. Okay, so let's construct myself a Venn diagram. Okay, now I'm not very good at drawing circles, but I'm going to try my best here. I'm going to try and make the circles as big as possible. So we've got 3,675. I'm just labeling which circle is which, and this is 84. And to do the Venn diagram, we're just going to go through the numbers and write out which ones overlap and which ones don't. So if I have a look at the 84 first, we've got a 2 there. Well, 2 doesn't go into 3,675, so that 2 is going to be on its own there, and this 2 here is going to be on its own. Okay, I think that's it. So the next one, now this 3 appears in both lists, so this 3 goes in the middle. The 5 here only appears in 3,675, and same with this one. And then we've got 1 7 that appears in both lists, but we've got another 7 in the 3,675 list. So that's my completed Venn diagram. Now, to answer question A, to find the highest common factor, all you need to do is multiply the overlapping ones together. So the highest common factor is 21, and that's it. There we are, it's that easy. Now, to find the lowest common multiple, which is question B, what you need to do is times all of them together, every single one. Now you might wonder, well hang on, surely that's just going to give us 3,675 times 84, so why couldn't I just do that? Well, the overlapping ones we're only going to write once. So the 3 and the 7 in the middle, we're only writing them once. So we would, if we did 3,675 times 84, we would be timesing by 3 and then timesing by 7 again. So we've already done the middle bit. So we've already done the 21 in the middle. And I need to do the ones around the side. So we've got 5 times 5 times 7 times 2 times 2. Now on the non-calculator paper, it might be a bit more generous with the numbers. This one is probably going to be more on the calculator paper, although there are ways that you can do this. For instance, I could pair the 5s and the 2s up, and that would make 10. The 5 and the 2 there would make another 10, so we've got 100. So all we need to do is 21 times 7 and then put 2 zeros on the end of it. 21 times 7 is 147, so put 2 zeros at the end of it. If it's on the calculator paper, you just literally use your calculator to times them out. And so that's 14,700. Well, the chances of us finding that with trial and error are close to impossible, so you can see why this method is so good. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Oh, always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether. Okay, the way you solve these is exactly the same as where you solve an equation. It's just you've got an inequality sign here. So we're going to put our lines in, probably way too long. And we're going to try and get x on its own. So the first thing we're going to do is take away 10 from both sides. So we've got 7x, and then this time don't forget, don't put an equal sign. You must do this inequality sign. And 77, and then we're going to divide 7 both sides. So we've got x is greater than or equal to 11. Now it's really, really tempting. And there we go, I've already made a mistake. It's really, really tempting to put an equal sign in there, but there have been in some exams in the past that you get 0 marks, even if it's a 3-mark question, for putting an equal sign. So remember to put the same sign. So to work out the volume of a prism, we work out the area of the cross-section and we times it by how 3D the shape is, which we call the length. So we're going to work out first of all the cross-section area. Now the cross-section is a triangle. So the formula for a triangle for area is half times base times height. So the base of it is 22 and the height of it is 14. So on my calculator I'm going to do 0.5 times 22 times 14, which is 154. And be careful, the most common mistake here is not to halve it. So with the triangle we have to halve it. And so the volume is the area of that triangle times how 3D it is, so 15. As I said, that's called the length. So times that by 15 and we get 2,310. So my answer is 2,310 centimetres cubed. Now a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assume they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and the way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good. And 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to two decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. Now, this seems like a really easy question that you just do 11 divided by 6 and times by 7. The problem that gives us is it basically means if we add a student, it takes longer. Now, the problem is that one looks at this question, thinks it's direct proportion. It's not, it's inverse proportion. So if we have a think about, well, let's label the two things. So we can have hours and students. Now, H is inversely proportional to the amount of students you have. So H equals K, which is our constant, over S. The hours is 11, and the number of students is 6 in our example. So I'm going to put the lines in and times both sides by 6. So it's 66 equals K, or K equals 66. Then when I go back to this equation here, we know what K is, and K is a constant, so it's always going to stay the same. So it's 66 over the amount of students. So for our example, it says that there's 7 students, so H is going to be 66 over 7. So let's type that in, 66 divided by 7, and I get the answer of 9.428 blah blah blah. So it says it wants it to two decimal places, so it's 9.43. Now, way of checking this is it took 6 students 11 hours. So you'd think with 7 students it would take less time, which it does here. So if you don't know or you forget how to do the inverse proportion, just literally times these two numbers together and then get that answer and divide it by this number here. Okay, the way of doing this question is to do a quick number line. Now we're going to put 130 in the middle. Now it's the nearest 10, so I'm thinking what would the next one down be? Well, if we had slightly less, if we had 128, it would still round to 130. So the next one down that it could have rounded to is 120, and the next one up it could have rounded to is 140. Now to find the intervals, we're going to work out the halfway between the two. So I'm going to work out this one here and this one here. So halfway between 120 and 130 is 125, and halfway between 130 and 140 is 135. Now, it says it wants h for the height, so we're going to put h in the middle. I'm going to put 125 to the left of it, and 135 to the right of it. Now, h could have been, h was greater than, but it could have been 125 as well. So we have a little arrow underneath a little equals underneath the inequality. H was less than 135, but it couldn't be 135, otherwise it would round up to 140, so we don't put the equal sign there. Now this middle bit here, that will always be the same when you're answering this question, when you're asked for the error interval. The letter here might change. It might be fussy and ask you for a letter, or it might not. It might just say, just use any letter. If it says use any letter, X or N or whatever you want to use is acceptable. But the signs here will always look like this for an error interval. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's minus 6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5, and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number, and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.000084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Now I'm going to be using the multiplier method for this question, but you might have a different method, and if it's working, stick with it. Okay, so to use the multiplier method, we need to work out what we're doing. So we're increasing by 1.6% because it's a savings account, and if your money goes down in a savings account, you wouldn't be happy with it. So to use the multiplier method, you start off with 100%. You do what the percentage, or you add or take away the percentage depending on the question. Here we're adding because it's going up by 1.6%, and we're going to end up with 101.6%. Then you work that out as a multiplier. Now to do that, all you do is you divide by 100, and all you're doing is convert it to a decimal. Multiplier is just a posh way of saying decimal. Okay, this is now our multiplier. Now whenever I times something by this number, the 1.016, it will increase it by 1.6%. So we've got £2,400, and if I just had 1 year, I would times it by the multiplier and it would work out what it is after the second year. But we've got 7 years, so what we could do is times it by 1.016 7 times, but I can't be bothered to do that because we know something better in maths. What we can do instead is do that multiplier to the power of 7, and that's just the same way as just timesing it by 1.016 7 times. And it's a bit easier to do. So 2,400 on the calculator times 1.016, and then I put my power button and I type in 7, and I get the answer 2,682.0520 blah blah blah. Okay, so because it's a money question, it can only have 2 decimal places, so 2682.05. Now the last step is really just to check that that makes sense. Well, we're in a savings account for 7 years, we've put in £2,400 and we've got out after 7 years 2,682 roughly, so 2,600. So we've made £200. Now the interest rate, the 1.6%, is quite a low interest rate, so we wouldn't expect very much money. So about £200 is about right. So you can always just check your answer to see if it makes sense. If you ended up with less money at the end, then alarm bells are ringing. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X. And I realise that it needs to be trigonometry, because this is a rectangle, that's a right angle. So I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse. So we're going to use sine. So SOH. So it's going to be sine 68 equals 27 over x. And I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual, because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough, but I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90, because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22, so that's 22 degrees. Now I'm looking for this one, so CE, I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH, so cos 22 equals x equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. Okay, so the important thing to realise first is that this is a part of a full circle. So if I draw the full circle in badly, we've just got a slice of it. Now it asks us for the perimeter. Now there are 3 parts to the perimeter. There's this 7 centimetres here, there's 7 centimetres here, and this what we call an arc here. So we need to work out the arc first. So to work out the length of the arc, we're going to do the full circumference of the circle, which is pi times the diameter. Now the diameter here is going to be 14 because the radius, the distance between the outside of the circle and the centre of the circle is 7, and the diameter is twice the radius, so that's going to be 14. But that will give us the whole circumference, and we don't want the whole circumference, we want just this 49 degrees of it. So we need to write that as a fraction, so 49, the total in a circle is 360, therefore as a fraction that's going to be 49 over 360, and it's always over 360 because the circle always adds up to 360 degrees. So I'm going to type that into my calculator. pi times 14 times, and I'm going to press the fraction button, 49 over 360. And it gives me the answer of 5.9864 blah 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 blah. I'm going to keep that into my calculator because I haven't answered the question yet, because as I said at the start, to get the perimeter I need to add that 5.9864 blah 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 to the 7 and the other 7, and that will give me the full perimeter. So I'm going to add 7, and it gives me 19.9864 blah 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 blah. So to 2 decimal places, that's going to be 19.99, because that 6 moves that 8 up to a 9. Okay, so box plot question. Now, it might be tempting to think that the information here is all you need to plot on the box plot. Well, it's not quite that simple. The 8 is the lowest, so I can plot 8. And the lower quartile is 16, so that's fine. I can plot that. And the median 19, I can plot that. But then I'm not given the other 2 that I need to plot. So to work those out, I'm given the interquartile range is 4. Well, the interquartile range is the distance between the lower quartile and the upper quartile. And if the lower quartile is 16, then the interquartile range will tell us that the upper quartile has to be 20, because we just add that on. So it's going to be here. So I'm going to do my box. Now the range is the biggest, take away the smallest. So if the smallest is 8, then to work out what the highest is going to be, then I just get the range, which is 14, and add on to the 8. So 14 plus 8 is 22. So the highest value is at 22. There we go, and that's our box plot. So that's question 1 done, or question A. Question B says, find how many students scored more than 20 marks. Well, 20 marks is our upper quartile. That means that 25% of the students scored more than 20 marks. So there are 140 students, so I just need to find out 25% of 140. And I can halve it, then halve it again, which is 35. So it's 35 students. Next one, question C. Estimate how many students scored less than 12 marks. So let's have a look at 12 marks. 12 marks is here. And 12 marks is halfway between the lowest value and the lower quartile. So we know there's 35 students who are in that quarter. And so we're going halfway there. Now we can't really say 17.5, that doesn't make much sense. So on this question I would expect that you could either write 17 students or 18 students. And what am I going to say? I'm going to say 17 students. It doesn't actually matter which one you write down, because you've shown that it's 17.5, well, you can't get half a student, so let's go for 17, or let's go for 18. Now this topic is brand new to the GCSE. I don't think it's ever been on the GCSE before, so it could be that all the resources you're using are a bit rusty on it. The idea is that you capture some things and you mark them all, then you put them back into the population, and then you capture a few more again, and then from that information, from the amount that you get back that are marked, you can guess, or you can have a really great estimate of the total population size. So it's typical for things that you can't just get all the fish in a lake and just know how many there are. It's just going to be impossible, because as soon as you count one of them, it swims off and you could count it again. And it's impractical to try and tag them all, especially with methods like capture-recapture from Peterson that allows you just to calculate it and have some really great estimates for it. Now, the best way of doing it is to know the formula, and the formula is as follows. n, which is the population size, that's what we're trying to find out, is this, it equals m. Now m is the amount of things that you marked and then released. So on our example here, we marked 4 times n. Now that little n is the size of the recapture sample, which is 4 here, over little m. Now little m is the amount of things in your recapture sample that were marked. So in our little example here, it's 2. So let's apply this to the question. Let's try and work out what m is. M is the amount of trout that we marked. So we marked 97, so that's going to be 97. N is going to be the size of the sample that we took again, so 60. That's our recapture sample. That's the sample then we took a few days later or the next day. So that's 60. And we're going to divide that by the amount of those 60 that were tagged or that were marked, which is 7. And so all you need to do is just type that into a calculator, which I've got handy. So it's 97 times 60 and then over 7. And now you always get, or you often get like a decimal. So I've got 831.428 blah blah blah. Now it says the number of trout, estimate the number of trout. So we have to have a whole number. So it's just going to be rounded to the nearest whole number. So that's 831. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what the a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. The number before the x is 7, and the number on its own is minus 4, and that's really important that you understand that that's not 4, that's minus 4. So when I substitute it in, so b was 7, so it's minus 7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's minus 4 times a times c. Now a is just 1, so we can ignore that. Minus 4 times c, which is minus 4. Well, minus 4 times minus 4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals minus 7 plus root 65 over 2. And we have x equals minus 7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then minus 7 plus root 65 over 2. And then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner, I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's minus 7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? Minus 7.53. So minus 7.53. There's our answers. So what this question is asking us to do is find the inverse function. That's what the f to the power of minus 1 means. And there's a really easy way of doing this. If we rewrite the function as y equals 4x minus 5, to find the inverse of it, we just literally swap the y and the x around. So x goes here and y goes here. Then the task is to try and get the try and get the y equals. Okay, try and make y the subject. So I'm going to go put my lines down. So the first thing I need to do is add 5 to both sides. So we're going to have x plus 5 equals 4y. And next thing I need to do is divide by 4 both sides. And the way of doing that really is just with a fraction. So y is x plus 5 over 4. Now we made up y. Y represented the function initially, and then it represented the inverse function essentially. So all we need to do is finish that off. So f to the power of minus 1 of x equals x plus 5 over 4. If I just put that into the answer box. Now there are other methods, but I've always found just writing y equals and swapping the x and the y around and making the y the subject by far the easiest method. But if you've got a different one and it works, stick with it. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator, you can just do 25 take away 13. If it's on an uncalculated paper, then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it and you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, oh, all right, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence. I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3. So it's going to be 3n plus 7. So we got our 3n squared already. And we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. Okay, so for this question, this is all about linear, area, and volume scale factor. So with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4. So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor. To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorise the top and bottom, so put them into brackets, and then something will turn up. So let's factorise the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorise the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3. Okay, so this question seems really complicated because the just sheer amount of words, but actually it's quite a simple question when you get your head around it. So the first question, we're looking at a bag or 2 bags of letters and 1 bag of numbers. And so there are 26 letters in the alphabet, so there's 26 options for this first bag. There will be 26 options for the second bag, and numbers from 0 to 9. Now we've got to be careful here because 0 is counted, so there are 10 numbers in that bag, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's also 0, so that's 10 in total. And to get the amount of combinations, all we do is 26 times 26 times 10. And we'll have a calculator for this, so 26 times 26 times 10, which is 6,760, which seems quite a lot, but there we go. This next one is, so he wants to use 4 digits, but limit the combinations. So we just got to read the question. His letter bags now contain the letters A to F, so that's A, B, C, D, E, F, which is 6. So these both will contain 6, and only contain even numbers greater than 0. Now, these are the same bags as before, so we only had the numbers from 0 to 9 before. So the even numbers that are greater than 0, so it's 2, 4, 6, 8. So there's 4 combinations. So there's 4 numbers those can be. And so find out how many different passwords if they're arranged like this. So 6 times 4 times 4 times 6. So 6 times 4 times 4 times 6, which is 576. Now, that might seem confusing that there's an extra digit to the password and yet less combinations. But if you think about it, there's significantly less letters and less numbers. So that's why it's a much lower number than part A. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from ka to ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9, because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, but the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was asked, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3, and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed. So 5 times 3 cubed is 135, so I know I've got it right. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now the beauty of this calculators, these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088, blah, blah, blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208, blah, blah, blah. So it says it wants the solution correct 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. The first thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now at A level there are much easier ways of doing this, but we at GCSE have to do this using the trapezium rule. Now the trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around. So that's, I think that's 11. I think that's 6. I think the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading, because h actually used in the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because A and B are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. And let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry, so 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area, so this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. Right, so this question looks a bit daunting, but if we break it down, it is kind of simple as long as you can kind of view things in 3D. There is a length that we need before we start answering what the length of AM is, and that's this length here. Now I'm going to call this length x. I'm going to use Pythagoras to work out what x is, and then we're going to work out what y is, which I'm going to call the height. In fact, why don't we call it h for height? That's probably more sensible. By using the value of x, or using half the value of x, using that 5 up the side, and using Pythagoras to work out what h is. Okay, so I'm going to draw out the two right angle triangles I'm using. Triangle DEB, first of all, to work out what x is. So that's DEB. And we call this one x, this one is 4 centimeters, and this one's 3 centimeters. And then we're going to work out what the height is. So it's a at the top, is it? Yeah. So it's A, M, D. Now we know this one at the bottom is going to be half of x, and we know at the top it's 5 centimeters. And this one we just go call h. Okay. So we're going to work out what x is first, and if you don't know how to use Pythagoras, there's loads of stuff on the site on how to do that. Now it's a 3, 4, 5 triangle actually, so let's do this all anyway. 9 plus 16, root 25, and that's just actually going to be 5. I would leave it as a root if it doesn't work exactly, so I'd leave it as a square root. Okay, so we know what this one's going to be. It's going to be x divided by 2, which is 2.5. Okay, so to work out what h is, I'm going to do the hypotenuse squared minus that length that we've just found out squared. And just get my calculator. Root 25 take away 2.5 squared, and it's 4.330 blah blah blah. So it's 2 decimal places, it's 4.33. And it's probably sensible to check that makes sense. Have a look at the numbers we've got in the question. Imagine a 3 by 4 by 5 rectangular based pyramid. Does that kind of make sense? And to me, yeah, that kind of makes sense. It's less than the 5 here, and since 5 is the hypotenuse on that triangle, it needs to be less than that. So yeah, it kind of makes sense. Okay, so we've got a linear and a quadratic equation, and so the way of doing these is slightly different. And if you notice that each equation has this y in, now y is going to be equal in both equations, so what we do is we just get the equations here equal to each other. So we've got 2x plus 11 equals x squared minus 5x plus 4. Now we can get them equal to each other because y, if we're solving, y is exactly the same thing. So we're just getting them equal to each other because they both equal y. And then we would need to get that, move that around so that we have equal to 0. So we're going to take away 2x both sides. So we've got 11 equals x squared minus 7x plus 4. And we're going to take away 11 both sides. So we've got equal to 0, which we need quadratics to be equal to. So was it 4 take away 11, which is going to be 7, so minus 7. Okay, so at this point we're looking at either factorising, which I doubt is going to work, or using the quadratic formula. I think we're going to need the quadratic formula for this, so we need to remember what the quadratic formula is. So minus b plus minus square root of b squared minus 4ac over 2a. We've got a is 1, b is minus 7, and c is also minus 7. Okay, it's going to take a while. So minus b is going to be just 7, plus minus b squared, which is going to be 49, minus 4 times a, which is 1 times c. So it's going to be, and you can use your calculator for this, so it's minus 4 times minus 7, which is positive 28, so it'll be plus 28. Okay, over 2. And so 49 plus 28 is going to be 77, so we can rewrite it like this. Okay, this is where we split the two apart. We have the positive version, so 7 plus root 77 over 2, and we have the negative part, 7 minus root 77 over 2. So the positive part, 7 plus root 77 over 2, is going to give us the answer 7.89 to 2 decimal places. Now, at this point, it's still in my calculator. Okay, I don't want to get rid of it because I need to also find out what y is. Now it says y equals 2x plus 11. So y equals 2x plus 11, which equals 2 times this value in my calculator plus 11. So I'm going to times this by 2 plus 11. And it gives me the answer of 26.77 to 2 decimal places. And those are my answers for now. And y is 26.77. Okay, let's carry on. And I'm going to type that in again. So 7, but this time minus root 77 over 2. And it gives me the decimal answer of minus 0.89. Again to 2 decimal places. So minus 0.89. And similarly, we know that y is 2 lots of x plus 11. So I'm going to times that by 2, and I'm going to add 11. And press the decimal button, so 9.23. 9.23. And that's to 2 decimal places. So it takes a bit of time, but if you make sure you write this part here down, then you can just split it up into a positive and negative.
Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, including the other 2 papers, please click subscribe. We've got loads and loads of stuff on the website on maths.com, which you can go to here, which is completely free. But if you feel you're quite far behind in the maths, or you're not happy with the grades you're getting on maths.com or other mock papers you have, you can try out our premium service, which is mathseffect.co.uk. With mathseffect.co.uk, it's a small monthly fee, and you can do an annual subscription, but if you only want to do it up until November, which makes sense, you can just pay per month. And what it does is it has the whole of the Maths GCSE as a journey, and you go through each topic, mastering it one topic at a time. A lot of the students I talk to say, I really don't know where to start. Like, I keep doing Pythagoras and trigonometry over and over again, and I don't really know what else I don't know. This is a service which just covers everything. It makes sure you master and you are an expert in every topic in maths. So it's worth checking out. Loads of people have joined already, and if you haven't joined, go to the website mathseffect.co.uk or click the link in the description. That will take you straight there and you can check it out. Otherwise, thank you very much. If you want to leave a comment down below of anything you want us to cover, because we're desperate to help anyone who's being caught up in this terrible situation, which is not ideal for anyone, but equally, like, we all understand why it's happened. But if I was having to resit or having to sit for the first time in November, I would feel exactly the same as you are probably feeling. So if you want to leave any comments down below, and we might release some videos just discussing options that you have open, or whatever it might be. Otherwise, thank you very much, and I'll see you in the next video.